Today in this video we will discuss about the factor theorem. Now we have already discussed remainder theorem in the previous videos. What remainder theorem stated was that if some polynomial say p of x is divided by a linear polynomial say x minus a, then the remainder which we get is p of a, right? So which meant that we can express any polynomial p of x as multiple of x minus a and some quotient polynomial q of x plus p of a, right? This is what we derived in remainder theorem. Now keeping that in mind, we will study the factor theorem. Now let's look at the case number 1. If r is the 0 of p of x, then x minus r will be factor of p of x, which means that, let us say, take a polynomial p of x and let it be a quartic polynomial, say ax square plus bx plus c. Okay. Now if we draw the graph of this polynomial, it will be something like this parabola. Okay. Now when we say 0 of polynomials, it means values of x at which y is equal to 0. So in this case, this value of x and this value of x, we get y-intercepts as 0. So these are the zeros of the polynomial. Okay. Now it says that if r is 0 of p of x, then x minus r will be factor of p of x. Now in this equation of p of x is equal to x minus r into q of, let me rewrite this, let's stop this as well. Yeah. So from the remainder theorem we can write p of x as x minus, now we are writing r because in theorem we have used alphabet r, q of x plus p of r. That what we are given is that r is 0 of p of x. When r is 0 of p of x, it means p of r is equal to 0. So when you put this value of p of r equal to 0 in, say, equation number 1, then what do you get? You get p of x is equal to x minus r into q of x, which means that this p of x is nothing but multiple of x minus r and q of x. Or you can say that this p of x is fully divisible by x minus r. Hence, x minus r is factor of p of x, and that is what we are supposed to find, right? So what we have done is that we have used the remainder theorem, and we are given that p of r is equal to 0. this equation comes from the remainder theorem, and then we have said that P of R is equal to 0. So we have substituted the value of P of R equal to 0 in this equation. As a result, we have got P of X is equal to X minus R and Q of X, and which means that X of X minus R divides completely this P of X, giving us a quotient of Q of X, and hence X minus R is a factor. Now in second case, what you have to do is that we have to assume that X minus R is factor of P of X, and when X minus R is factor of P of X, then what we have to prove is P of R is equal to 0. That is, R is the 0 of the polynomial. Again, it is very simple. So we can write P of X is equal to X minus R into Q of X plus P of R. Again, this comes from our remainder theorem. Now, if X minus R is the factor of P of X, then it means that X minus R fully divides P of X, leaving remainder 0, which means R remainder is 0. Right? When our remainder is 0, and what is the remainder here? P of R, or P of R is equal to 0. Hence, R is 0 of P of X. So there are certain theorems which can be proved just by logic or being so obvious. Now let us take an example. Let us take an example of an equation of a polynomial, say x cube plus 2 times x to the power 2 minus 5 times x minus 6. So this is the given polynomial, and we are given that 2 is one of the zeros of polynomial P of X. Okay. Find other zeros. Now, from this fundamental theorem of algebra, we know that if a polynomial is of degree 3, then it will have 3 zeros. How many? 3 zeros. Why? Because fundamental theorem of algebra tells us that a polynomial of degree n will have n zeros or n roots or n factors, right? So we are talking in terms of zeros, so we'll say that it will have 3 zeros. Now 1 zero given is 2. Now we can express this polynomial x cube plus 2x square minus 5x minus 6 as what? Multiple of x minus 2, the divisor, and some quotient polynomial, right? Now it means q of x will be equal to x cube plus 2x square minus 5x minus 6. This whole is divided by x minus 2. Now let's use the long division method to find the quotient polynomial. X cube plus 2x square minus 5x minus 6. So whole gets divided by x minus 2. This times x square gives us x cube minus 2x square. This x cube gets cancelled with x cube, giving us 4x square here minus 5x. So it gets multiplied, x minus 2 gets multiplied by 4x, giving us 4x square here minus 8x. Now this 4x square cancels 4x square, giving us 8x minus 5x, that is 3x minus 6. And when we multiply it with 3, what we get is 3x minus 6, and this whole gets cancelled with 3x minus 6, gives us the remainder of 0. So which means that this polynomial x cube plus 2x square minus 5x minus 6 can be expressed as multiple of x minus 2 into x square plus 4x plus 3. Now what we do is that we further divide this, we factorize this. Okay, and we have learned how to factorize the polynomial. We first split this middle term in such a way that sum of the split terms is equal to the middle term, value of middle term, and the product is of those two split terms is equal to the product of first and third term. So let's split 4x as 3x plus x, and we are put here as remainder 3. So it is x minus 2. Now what we do is that we take a factor common from these two terms and these two terms. X square plus 3x, we can take x common, and then we can take one common from x plus 3. Let me show how does it look. Take x common, so we are left with x plus 3, and we can always write this as 1 into x plus 3, right? 1 into x plus 3. Any number or any value multiplied by 1, it remains unchanged. Yeah. So, x minus 2 continues to be here. Now, look here. X plus 3 is a common factor in this term, and x plus 3 is a common factor here as well. So, again, taking the method of greatest common factor, we can take x plus 3 common. We are left with x plus 1 here, right? So which means that now we have three factors: x minus 2, x plus 3, and x plus 1. Now what were we given? We were given that that 2 is the 0 of polynomial, and we were supposed to find the other zeros, and we also knew that it's a cubic polynomial, so it will have 3 zeros or 3 factors. So now we have found the 2 factors, and so what are going to be the zeros? Now take a pause and just see what is going to be the 0 here if x plus 3 is the factor. It is minus 3, and here minus 1. Zeros of polynomial are 3, minus 1, and 2. With this, we end our presentation on factor theorem. Thank you.